Is time constant? Are we always travelling through it at the same speed? And if not, why? We're going to have a look at this concept. First, it is important that we understand space, as the two are more than just closely linked. For many years, it was postulated that space either comprised of or was permeated with what was known as the ether, which acted as a medium for things like light and force carriers to act through, as well as an absolute reference point. The earliest use of this idea is dated all the way back to 360 BC by the philosopher Plato, and evolved through thousands of years until it was eventually disproved by the Michelson-Morley experiments of 1887. This gave way for some of the most famous theories in all of physics, Einstein's theories of relativity, in which he marries space and time, postulated that they actually exist as one singular space-time fabric. The theory of special relativity, published in 1905, showed not only that the ether could not have been an absolute reference frame, but in fact that there was no absolute reference frame with which to measure motion against. Einstein proved that the only thing constant in all frames of reference was the speed of light, the universal speed limit. Using special relativity, a phenomenon known as time dilation can now be explained, which states that the faster any object or frame of reference moves up to the speed of light, the slower through time it will move. In order to demonstrate this more clearly, we will look at what is known as the twin paradox. Imagine two twins, hypothetically born at the exact same time. One twin boards a rocket and orbits Earth at close to the speed of light for a long time. After an arbitrary number of years, this twin will land back on Earth and find that they have aged significantly less than the twin that has remained on Earth, despite the fact that each of them will not have noticed that time has passed differently for them. The twin that has been orbiting Earth at close to the speed of light has actually experienced time passing slower than the twin that remained on Earth. The speed of an object or reference frame is not the only thing that may influence time. Time dilation can also occur as a result of curvature of spacetime, which Einstein describes in his theory of general relativity, published 10 years later in 1915. Through this, he shows that objects of mass and their subsequent gravitational fields may distort spacetime such that when you are near an object of mass, time will actually slow down as well, with larger objects having a larger effect of slowing time. Through all of this, we eventually reach the inevitable conclusion. If an object is travelling at or close to the speed of light, or finds itself within a powerful enough gravitational field, such as that at the event horizon of a black hole, there is a point at which the object will not just be moving slower through time, it will find itself not moving through time at all. Several important questions for physicists arise from this. Is it such that we will never be able to reach the speed of light because of this? How much do the mass of things like the Earth affect our perception of time? What happens to a person or object that is not moving through time at all? These are all questions for the physicists of tomorrow. As for if there are any answers to them, only time will tell.